In this video, we are going to start looking at functional groups and nomenclature. Specifically, we're going to start looking at some functional groups and look how to name them. The first one we are going to look at is alkanes. So alkanes are saturated hydrocarbons with a general chemical formula of CnH2n plus 2. They have a degree of unsaturation of 0, i.e. they do not have any double bonds or triple bonds. The exception are cycloalkanes, which are similar but happen to have rings. These compounds tend to be hydrophobic, meaning that they do not mix with water. When naming alkanes, we look at the number of carbons the molecule has. For example, a single carbon alkane is a methane. A 2-carbon alkane is an ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. You need to learn these prefixes so that you can apply them to any structures you encounter. The structures shown are referred to as linear, straight chain, unbranched, or just normal alkanes. As previously mentioned, there are a subgroup of alkanes referred to as the cycloalkanes. These are ring structures with the same number of carbons. Well, it turns out these prefixes are still used to describe the structure, except instead of them being prefixes, they are the root name. What do I mean by that? I mean that if we have a 3-carbon ring, we would say it's cyclo, for it being a ring, and then propane, because it's still a 3-carbon alkane. So cyclopropane. For 4 carbons, it's cyclobutane. 5 carbons, cyclopentane. 6 carbons, cyclohexane. So, what would a 7-carbon ring be called? Pause now. And yes, you are correct. It is cycloheptane. You might be thinking though, what about non-linear structures? What about branched compounds? These are probably constitutional isomers of these linear structures. How do we differentiate between these constitutional isomers? How do we name them differently? Well, for that, we need a very systematic way of naming them so that we are consistent. Thankfully, there is the IUPAC method of naming. The current standard in systematic naming in organic chemistry is called IUPAC Nomenclature. A name will look something like this: 2-methyl butane. We can break the name down into a root, which is how many carbons are in the base chain, the suffix, which will tell us any functional groups in the base chain, and then the number and prefix, which tell us what is coming off of the base chain and what those things are. So for example, methyl is saying that we have 1 carbon side chain, and the 2 is saying that it is on the 2 position, i.e. if we started counting from one end or the other, it will be at the 2nd position. Now, to be able to know your roots, so you know what to call your bases, you need to learn those prefixes before. Here we go again, the number of carbons. 1 carbon, the root is meth. 2 carbons, root is eth. 3 prop, 4 bute, 5 pent, 6 hex, 7 hept, 8 oct, 9 non, and 10 dec. If any of these is on a side chain, we add a YL suffix to the root. So methyl, propyl, pentyl. Okay, so let's draw out the structure of 2-methyl butane. You may pause now. And here we go. So it's 2-methyl butane, the root is bute, so we draw 4 carbons. It's an alkane, so there are no double bonds. On the 2 position of this 4-carbon chain, we have a methyl group, so we draw a methyl. And there we have 2-methyl butane. When given a structure, there's a 5-step method of being able to name the structure. Step 1 is to find the longest continuous chain in your system. For example, in this example, we have a longest carbon chain of 7. Step 2 is to check what is the functionality or the main functionality of your base chain. In this case, it's an alkane, so the suffix is ane. Step 3 is to number the carbons in the base chain or the root chain. You start at the end that is closest to a branch. So in this case, on the right side. Step 4 is to name the side chains, if there are any. In this case, we have an ethyl and a methyl. And finally, step 5, where we assemble the name as a single word. For example, you gotta state the positions your side chains are, what your side chains are, what the root name of your base is, and then the suffix as your functionality. If you happen to have multiples of the same side chain, this is not a problem. You can actually simplify it by putting them together with a prefix. So if you have 2 methyls, you could say it's dimethyl. If you have 3 methyls, it's trimethyl. 4 methyls, tetramethyl. You see the gist of it? Now it's time to practice. Name these following structures. You may pause now. And here are the answers.